Well, as you know from your previous subjects, when you went into the school, the main purpose of differentiation is to maximize or minimize the value of a function so you can solve engineering problems with a few calculations. In the case of the multivariable differentiation, uh, there's a technique which is named gradient vector maximization. And once you know how to do vectorial calculations, once you know how to calculate partial derivatives, once you know how to calculate the unit vector, the magnitude of a vector, the modulus of any vector calculation, cross product, dot product, and so forth, let's start to work on some practical examples. In this picture, you have a mountain in Norway, and let's think and let's suppose that you are a professional climber and you're about to climb this mountain. So, one of the questions could be, in what direction will you go up faster? In what direction? If you are here and let's say this is point P and this is your starting point, and you want to know how to go faster, will you need to go in this direction? What is the change in the height with respect to the amount of distance that you are moving? If you go in this direction and you are walking the same distance, do you think that the height is going to be different or higher from the point P? Or if you change the point P here, or let's say this is point Q, do you think if this pattern, let me change the color of green. Do you think if you go in this direction, you will climb faster? What direction from point P over point Q represents the fastest rate of change in height? Okay, this is a real life example, but this mountain here is the surface that we built with a function. So, in matter of doing in a mathematical way, this is point P, and now we have this point Q as the final point of some movement along some direction. And one of the purposes of the gradient vector, which is this nabla operator for f, is to know in what direction we need to go to maximize the value of a function that is in multivariable uh, mode. Okay, so if the function f is a differentiable function of two or more variables, then the maximum value of the directional derivative d sub u or f of x Now here I am changing a little bit the notation. I am using f of a bold x because this is equal to f of x, y, z, q, r, up the way up to any amount of functions, okay? So this is not only a function of a single variable x. I am represented here, representing this bold x as somehow tell you that you can have a two variable, three variable, four variable, or n variable function. So the directional derivative of any function of multivariable is the magnitude or the modulus of the gradient vector for that function. That is the maximum value. And it occurs when the vector unit vector u, which is the vector that is giving direction to this directional derivative, has the same direction as the gradient vector of this nabla f x bold x. So in this case, we have here, this is the gradient of f, which is this vector. And if you see, it's going in the direction where the function is getting the maximum value. But here we have another vector which goes from P to Q. And what do you think will be the direction of the maximum change? Of course, the direction of the maximum change is going in the direction of the gradient vector. So the direction from P to Q does not represent the maximum value for the function in the path. In order to have this unit vector to go from this direction, you need to have this line and this line going in the same direction. So the answer to this question is how to find the two vectors if the two vectors are going in the same direction. Well, this is an easy one. You already know that how to calculate the angle between two vectors. So if you add some additional steps to this formula, you will end up with this d sub u f is equal to the, you know that this is directional derivative is equal to the gradient vector times the unit vector. And if we calculate the magnitudes of this gradient vector times the magnitude of the unit vector times the cosine of theta, you will end up with this magnitude of the gradient vector times the cosine of theta, where this theta value is the angle between the gradient vector and the unit vector or directional vector u. So if this angle between these two, or theta, is equal to 0, then the maximum value of the directional derivative is in the direction of the unit vector. This is also known as the steepest ascent. Okay, and you are going to deal a lot with this, even if you do robotics or no, or not. You are going to deal with a lot of this in the field. And this is a pure mathematical way to get the steepest ascent, but there is other ways in matter of experimental data that you will learn in the way by applied math to get this steepest ascent. Because most engineers, they are required to optimize the cost, to optimize the use of the resources, to optimize the uses of the energy, of time, of temperature, and most of that calculations are performed in this way. Okay, well, I hope this is fairly clear. Let's continue with this maximizing gradient vector with a couple of examples.